All right, so next up, we've got Justin James from the Consortium, iRODS Consortium. He's going to talk about the work that he did in the last year with the Globus organization and with the community and building the iRODS Globus Connector. Go for it, Justin.
Okay, and I want to thank Vas for doing that, his presentation. That is really helpful for me. And I'm glad he preceded me because he was able to tell the Globus story a lot better than I could. So thank you. Okay, and here's another quick overview of the iRODS Globus Connector. We're calling it the iRODS Globus Connector. It is a plugin to Globus and a client to iRODS. So any connection between the connector and iRODS uses the iRODS C API. So if you look here, you see that we have some Globus clients, talking to Globus, and which gets routed to the, if it's talking to iRODS, it gets routed to the plugin or the connector, and anything will go through the iRODS API, and then on the back end we can have S3, Unix file systems, whatever, and the iRODS policy would still be invoked. Okay, this is built on work done from EUDAT. The GitHub link is shown here. They did all the initial work on this, and then we forked their repository and made some changes and had some bug fixes in the last year or so. And my talk is less about Globus and more about the plugin and what we have done, mostly about what we have done in the last year. Okay, so again, it's from the iRODS perspective. Voss did a great job of talking about Globus, so there's no need to go into that. So I'll talk about the implementation details, limitations of the plugins, improvements that we've made, and the iRODS APIs used by the plugin. Okay, so basically, the Globus plugins have to implement the Globus GFS storage IFAST interface. Among those are a lot of methods that you have to implement, and we've only implemented a subset of these that are important for us. First is init, is called when a new session is initiated, and that would call the client login. When the session, end of a session, we call it destroy, which cleans up everything and calls RC disconnect. Then you have send and receive, which basically send is when a client requests to receive a file, and receive is when the client requests to transfer a file to the server or to another file system or something. These seem a little backwards, but this is all kind of looking from the names of these are from the perspective of the server. So again, we call a lot of RC calls open, seek, read, close, and when we write, we call write. Then the plugin can receive commands, and I'll discuss those in the next slide. Another one is stat, which is either calls like RC object stat, or for a collection, it'll open a collection, it'll read the collection and close the collection. So that can give you a listing. And then there's also a function for the row path feature. Okay, so those commands that you saw in the previous slide, the different commands, these are the ones that are implemented. They're all kind of self-explanatory. Make directory, remove directory, delete, all call, collection create, remove collection, and data object unlink. And then the fourth one is the checksum request, and I'll go through that in the next slide. Okay, so the Globus client may specify a hashing algorithm I'm gonna call it hashing. Globus calls it checksum. I think they're more hashing is, a lot of these algorithms are more hashing algorithms. So originally the hashing algorithm, the version of the plugin, the first version that existed prior to recently, returned the iRODS checksum that was in the catalog. This didn't necessarily match what the client was requesting. So we had to rework that, and that's one thing we did in the last year. So to support the client requested hashing, we now, the plugin will now calculate the hash itself and store those in metadata, where the name will be the specific algorithm, the value will be the actual value of the checksum, and the units will be the POSIX time that the checksum was calculated. In addition, we've added additional algorithms. iRODS only supports MD5 and SHA-256. We now support SHA-512, Adler 32, and there's something I'm missing. But so we support basically the 5 main hashing algorithms. Okay, my window is not updating, so. Okay, so here's how we do the hashing, or we return the checksum that's requested. So the plugin receives a request for a hash for a certain data object and the algorithm. It will query metadata for the key that's Globus : whatever the algorithm is. If it exists, it's just it's going to compare the unit, which was the time that the checksum was calculated, and compare it with the update time in iRODS. If the update time in iRODS is greater than the time that we calculated the checksum, then I'm sorry, if the update time is less than or equal to the time that we calculated the checksum, we'll just return the checksum from metadata. So the metadata acts as kind of a cache of the checksum. Otherwise, we'll remove the existing AVU for that algorithm, and in all cases, except for the case where we just return the checksum immediately, we'll download the file and calculate the checksum, write the checksum to AVU, and then return the checksum. So any subsequent requests for that algorithm for that data object would just be returned from cache. Okay, another change we made in the last year is support incremental directory listings for large directories. So after either X number of entries are encountered or Y seconds have passed since the last partial listing, we'll send additional entries via this Globus grid FTP server finished stat partial. Originally, we were just sending Globus grid FTP service finished stat, but now we've broken it up into partial listings. We also implemented heartbeats for long-running checksums, implemented the real path feature, so alternate paths don't allow users to bypass the Globus path restrictions, and fixed some memory leaks that were found. And that was mostly the people at Globus that helped us find and fix those. Sorry, I'm waiting for my screen to refresh. Okay, make sure I didn't, skip these slides. Okay, so future enhancements. One of the things about the checksums are that, reading the file and calculating the checksums might not be the best way to do it. So we want to kind of plug into the iRODS infrastructure, kind of at the same places that iRODS does its current checksums. We want to plug into that and write a policy that will calculate whatever checksums the administrator wants to calculate at the time that the object was updated. So we don't have to reread a file and calculate the checksums. And also look at any performance issues that have arisen. And that's it for me. Questions? Oh, sorry, I did have one more slide. So if you wanted more information on this, Globus has made a really good document on the iRODS plugin. So you can refer to this link for that information. Okay, questions?
Very good. I think got a question incoming. So Alan's asking, is the Globus iRODS plugin, the connector, is it calling the iRODS C APIs directly, or is there a C++ client refactor? What's the?
Oh, I mentioned I meant to mention this, and I think I forgot to put it in the slides. One thing we did do in the last year was we updated the code to use more C++ when possible. So we took the C code and added some C++ on top of it. I'm not sure if that answered the question, but the C API is called directly from the C++ code.
Excellent. And then favorite question, what was the most surprising thing we learned in doing this exercise?
Most surprising thing.
Something we didn't see coming.
Some
of the checksum calculation seemed to be surprising.
Yeah, it was interesting. I actually kind of enjoyed doing that, working on the different checksum algorithms, and those new checksums have been incorporated in the new iRODS code base.
That's right.
Even though they're calculated by the client right now, they are in the iRODS code base. So if iRODS wanted to implement those checksums, they could.
Yeah, the math is already there. We just haven't wired them into parts of the APIs and commands.
Yeah, and also another thing about the checksums is that we're presenting them in hexadecimal rather than
right. That's right. To store them cleanly because of the protocols. There is one question from Tan. It says, what happens if there are multiple replicas with different sizes? This is a trick question because that shouldn't happen, but
that is a good question. I'll have to look at the code and see.
So right now, is it asking for particular replicas, or is it just asking for? You just ask the iRODS API for the code for the data.
It is just asking the iRODS API for the data object because it's reading. That's right. Well, so, except in the case where it's even for the case where it's cached in metadata, that there's only one metadata. There's not per replica metadata, right? So
yeah, it's not per replica, and also you should not have two different file contents with different sizes both be marked good in the catalog. So in theory, a read request would only hit the good one, whatever that is in the catalog.
Right. And I guess the only question is the update time that I'm reading. And that's a good question. And I'll have to look and see.
Yeah. I think the update time also comes from the good replicas. So yeah, otherwise we would be, I think Corey would have fallen in a situation earlier with the M-time updates and stuff too. So,
right.
Yep. Very good.
Thank you.
Thank you.